Hi, my name is Lakshmi Prasanna Chorsetti, and I'm going to give a presentation of the project for the course Operating System for Fall 2025. The title of the project is Real Time Operating System for Embedded Computing. In this project, I'm going to typically give an explanation about the introduction, the history of our RTOs, and I'm going to compare three different RTOs which have really distinguished differences, and I'm going to conclude with the future scope of RTOs. So, introduction. Real time operating systems enable deterministic execution critical for embedded systems with timing constraints, prevent system failures in safety critical applications, essential in automotive, aerospace, and medical domains. In this project, I'm going to focus on three different RTOs. Those are ThreadX, Integrity, and PikeOS, which are used in different domains, like the aerospace one in households, and one is like a traditional RTO. Coming to the history of RTOs, the development of real-time systems emerged from early industry control applications in 1970, where microcontrollers first replaced mechanical relays and analog circuits. Early RTOs implementations were monolithic and hardware specific, offering fast interrupt handling but limited probability. As embedded computing expands into telecom, space systems, and consumer electronics, the need for scalable scheduling, deterministic memory allocation, and portable API driven kernel gave rise to modern RTO architecture. Uh, Coming to the core characteristics of RTOs, RTOs are deterministic task scheduling based on priority, fast and predictable interrupt handling. RTOs have low context switch latency, real-time intertask communication, memory protection, and false isolation. The essential RTO components are scheduler, tasks, events, timers, message queues, ISRs, semaphores, kernel services. Scheduler manages and prioritizes task execution, where tasks are the fundamental units of execution. Events are the signals for intertask communication, and timers handle time sensitive operations. Message queues enable task data and exchange. ISRs respond to hardware and software interrupts. Semaphores manage shared resource access. Kernel services core management functions. Coming to the first RTO that I'm going to compare among the three are the ThreadX, which is Azure RTO. Known for its compact memory footprint and speed, it prioritizes preemptive scheduler preemption threshold, reduces jitter, used in consumer IoT and wearables. This RTO is usually used in the household devices, more like the Internet of Things devices, like the refrigerators, the lights that are sensitive to, like, if you clap, the lights get off, those devices like that. Best for low risk and resource constrained devices. Coming to the second RTO, which is the integrity RTOs, these are microkernel model which protect partition. It is known for its high level of safety. It is used in like the aeroplanes and the medical industries and the defense. It prevents system-wide failures, which is more sensible and needed for the critical operations like the military, the aeroplanes, and the medical devices. Best for safety critical systems required certification. Coming to the third RTO, which is the Pike OS. This is like the more like a traditional RTO. This is the combination of an RTOs and hypervision combined in one platform. Uh, it is mixed critical partition scheduling, enables multiple applications without interference, best for aerospace and defense applications. Now, comparing these three RTOs for their task scheduling, it is Coming to the ThreadX, it is preemptive priority with indexed lists, whereas integrity hierarchical prior partition scheduling, while Pike OS time partitioning and NIC 653 windows. Uh, Talking about the interrupt handling strategies, ThreadX direct execution with minimal directions, whereas integrity is protection aware with boundary enforcements, whereas Pike OS partition specific and interrupt routing. Uh, Coming to the performance evolution, ThreadX excels in speed with microsecond level context switching on platforms. Integrity sac- sacrifices raw speed for reliability and safety, whereas Spike OS balances both, offering deterministic partition and scheduling ideal for mixed workloads. Strengths and weaknesses of ThreadX. ThreadX is extremely small footprint, fast switching, simple API, and IoT ready. And its limitations are lack of memory partition because it has a very compact memory space allocated for it, usually for the simpler tasks that are assigned to a specific device like the refrigerator or air conditioner or automatic doors. And it has the debugging challenges not for high risk. Integrity. The strengths and weaknesses of the integrity are the strengths are it is certified microkernel fault isolated aerospace proven, whereas its limitations are it has high overhead, it kind of deals with a lot of tasks which will put a pressure and load on the processors, and its licensing costs are high, and it is complex configuration. Coming to the Pike OS, the advantages are it is multi-partitioned, it is formally verified, and it is isolated. And its limitations are because of the multi-partition, it also have a high overhead, and it is formally verified and isolated. Evolution of embedded real-time systems. From simple control loops to complex multi-core systems, shift from 8 by 16 bit to 32-bit ARM and RISC-V architectures. Integration with IoT and cloud environment. Enhance security and formal verification efforts. So the IoT over time, IoTs have developed a lot. Before they used to be a 8 by 16 bit, now they are 32 bit, and they have evolved from normal regular devices to IoT devices and now to cloud environments. And also many security enhancements were made in RTOs, and many verifications are being done. So these are the basically the evolution of RTOs. Now coming to the emerging trends over the past years, Internet of Things has become popular, and it is more energy efficient, and later we got introduced to the artificial intelligence with the integration for edge computing and multi-core and heterogeneous processing supports enhanced security and privacy measures. Key drivers: expansion of embedded systems in automotive and healthcare, growing complexity of real-time applications, integration with cloud services and AI, and also standardized efforts. The conclusion. So, selecting and deploying an appropriate RTO demands careful evaluation of factors like hardware, software compatibility, as well as the system specific operational needs. Developers must also navigate challenges such as resource limitations, security risks, and portability issues. Despite these obstacles, the outlook for RTOs remains strong, with growth driven by the expanding embedded systems market and the increasing demand for real time capabilities and intelligent functions. By integrating advancements in areas like AI, cloud computing, multi-core processing, and enhancing focuses on security and open source collaborations, RTOs are well positioned to power the next wave of smart, connected technologies. Thank you.